cooking? We're cooking. All right. So, this is 300, right? All right, so this is a continuation of 250. I am going to do some things a little bit different than I've done historically to include some stuff that isn't really being covered in some other classes. So we're going to actually do some database connectivity stuff in here. That's things that you do need to have for getting jobs in industry and typically wouldn't be covered in here, but doesn't seem to be covered anywhere else. So we're going to do that. Over the next couple of days, we're going to kind of review the stuff from 250. We're going to start that today. It's the normal, and the syllabus is up on Blackboard. You can go look at it. It's the normal 60% homework, 40% exams. If you do better in the final than you do in your midterm, I'll replace your midterm exam with your final exam. So that, the normal jazz. We're going to be, we use GitHub last semester, right?
No, we talked about we didn't.
Okay, so we'll use GitHub this semester as well, so you'll learn that skill. We'll get to that when we get to it. All right, any questions at the high level, or are we just good to go?
Did you turn on the recorder?
Yeah, recorder's on, right here. You see it?
All right, so where's Fahe here?
Who?
Awesome dudes.
What is up, guys? AwesomeToots.com. All right, so what was I doing? Okay, let's go here. Isn't it funny how cold it is today, yet we're going to be pining for this temperature tomorrow? Tomorrow's supposed to be like negative 60 wind chills. It's going to be awesome.
Oh, wow, that's gonna be fun. I was gonna stay inside. Yeah.
Too bad we can't do that here.
I know. It's such a shame we can't stay inside here.
All right. Okay, so at a global level, what we're going to be talking about this semester is something called data structures. And we're going to think about data structures, and we're not going to really give it too much meaning right now, but this is kind of what we're going. So this class traditionally is a data structures class, and we're going to accidentally learn data structures in the context of doing Android applications with database connectivity. So lots and lots of kind of real life application experience doing things that will be beneficial to you. So you'll still get all the good stuff with some extra good stuff and more opportunities to fail and stuff like that.
Good.
That sounds great. All right. So I'm just going to put one note here. I'm going to say not an upgrade to arrays, but an alternative approach. And that'll make some sense once we kind of get to that. So in our first class here, let me save this.
Oh, I like that.
Like what?
The 4 in there before the I was like spring.
Oh, that was a good one?
Yeah.
It was like leet speak?
Yeah, I think so.
Do everything with numbers and stuff like that? All right, so what we're going to do today is we're going to review something that people didn't do well on the final exam related to this in 250. So we're going to assume that maybe it wasn't covered cleanly enough or something, so we're just going to cover it again. So we're going to talk about creating our own objects. All right, so what we're going to do today is we're going to create our own objects. We're going to throw it into an array, and we're going to put it into a list view in Android. So something that we haven't done yet, but basically have a screen that has a whole bunch of stuff in a list, and you can click on individual list things and have it say, hey, you clicked me, what do you want to do? That type of thing. Okay, so if you ever used a mobile app that you go to some page and it has search results or something, you can scroll through and say, I like that one, and then it takes you to another page. We're going to do that, but we're going to create objects deal with it. All right. So we're going to go back to our, when we create an object. So we've talked about historically the difference between primitive types and object types. So primitive types are variable types that are built into the language, and all they can do is hold a value, right? Okay, so that's like our byte short, int long, char, float double, boolean, those dudes, okay? Now, they allow us to do a whole bunch of individual things, but we do hit some limitations with those. So that's where we started getting pretty good practice with like strings. Okay, so strings are kind of like super primitives. They're technically objects, but they kind of act like primitives in Java, and they're kind of a poor, from an education perspective, they're a poor first example of objects because they don't act like other objects. Mm-hmm. All right, just because of the way you create them and things like that. But sometimes we're going to need to store special kind of information. Okay, not just an int, not just a float, not just a string. Maybe we want to hold two strings, a integer, and a boolean, something like that. So we want to kind of build these custom objects for holding interesting types of things. Okay, so in any of our modern object-oriented programming languages, we have the ability to create our own data types. Okay, and we'll call those objects. All right, so the keyword for this is a class. So a class is I'm going to say Java keyword, but the reality is that's the C++, C#, Swift, Objective-C, pick your object-oriented language, it's called a class. Okay, so this is any object-oriented language keyword for creating our own data type. All right. Now, classes are collections of three things. Remember what those three things are? Okay. Methods would be one of them. Starts with an F. Fields. Pick your favorite F word. Okay, we're going to count down from 3. Everybody yelling at 0. Constructors, good. Okay, so these are the three things that make up our classes. All right, so fields, these are variables owned by the class. I'm going to say or instances of the class. That comes back to whether it's a static or a non-static field, but we'll see examples of that, so don't worry too much about that. Let's remember the high level of these. Okay, so fields are variables. So a class has variables associated with it. So for instance, if I have a patient record field, so if you think about a dental office or something like that, and they open, you go in, you check in for your appointment, they bring up your patient record, you probably have a first name, a last name, a date of birth, an age, stuff like that. Different pieces of information, attributes, if you will, associated with that object. That's what our fields are. Okay, that makes sense? Here we can even put this. These are the attributes associated with our object. All right, then we have methods. So methods, these are reusable chunks of code that we write once and they can do things multiple times, right? So it's no different than methods we've been writing since really 200. All right, so these are reusable chunks of code that we write once and can call upon multiple times. Okay. Now the reality is when we write a method for an object, it's probably going to be a method that does some sort of operation on that object. Okay. Now a method's a method. This has more to do with maybe the kinds of methods we might want to write. Right. So for example, we might have a method for a patient record that kind of pretty prints their name. First name, last name, maybe open parenthesis, date of birth, something like that. So it kind of looks nice on the screen. So maybe we have a method called display for a patient record that kind of spits it out on the screen in kind of a nice way. But you can have any sort of method. Okay. Now, when we think about methods, methods have a return type, a name, and a comma delimited list of parameters or inputs. Okay? So far, so good?
Hang on, what is that?
Who? What?
The comma delimited list of.
Like if you have a method called addNums and it takes in an int a, comma, int b, and then you return a plus b. So comma delimited int a, comma, int b. So it's your parameters that are coming into it. So when you write a method, you might have a method that takes no parameters, right? It might just do something. Okay? Otherwise, you might have a method that takes 10 different inputs in order for it to accomplish its task. All right? So for instance, if we use that add numbers example that I just said, if I just walk up to V here, I say add numbers. You don't know what to do, right?
We'll add numbers, but
What numbers? Okay? So the no argument or the zero parameter version of add numbers doesn't make any sense. Okay, if I walked up to you and I called upon that reusable ability, all of you know how to add numbers, right? But you probably, in order to add, you need me to give you at least 2 numbers. Otherwise, you can, I guess, make up numbers to add together. Okay, but generally speaking, if I just walk up to you and say, Blaine, add some numbers, and then you're going to say,
5.
what numbers, right?
Yeah.
Okay, so that would be an example where we do need to give it some parameters. Okay, as opposed to no parameters, which is like me calling add numbers and not giving you anything. You don't know what numbers you're supposed to add. All right, so add numbers probably would take in 2 integers, and then it would add them up and spit the result back. Okay, so return type is either a type or void if we do not return a value. Luke. Don't you wish I forgot things? All right. Okay, so remember there is a difference between returning a value and printing a value. Okay? Just remember that. We'll see plenty of examples of that. All right, so that's what a method is. Okay, now constructors look kind of like methods, except they do not have return types, and their name must match the class name. Okay, and I'll share this link on Blackboard, so you'll have a link to the presentation up there.
I think it would be benefit me if you give me an example of fields and constructor. Just like.
Yeah, we're going to.
Okay.
Yeah, that's what we're doing today. I'm giving you the high level first, then we'll see this in practice. All right? All right, so constructors, these look kind of like methods. That is, they take in a comma delimited list of parameters to accomplish something, but they don't return a value, ever. So no return type, not even void. And the name of the constructor must be identical to the name of the class. It's like a rule in Java. It's also a rule in C#. Some other languages, they don't have to match the name. But okay, so that's the components of a class. Fields, methods, constructors. Okay? Constructors are used for creating new instances of a class. Fields hold the attributes associated with the class, and methods do functional things related to instances or the class itself. All right, so they allow it to do magic tricks. All right, and that's kind of what sets classes apart from our primitive types. Primitive types can only hold a value, where classes can hold 0 or more values and potentially do more by having methods that operate on them. All right? So, what we're going to do today is we are going to create a patient record. All right, so we're solving this as we're going to kind of create a simplified patient record so we don't have 4,000. You kind of imagine if you go into a doctor's office and they bring up your patient record, there's probably 15 or 20 different data points they keep track of for you. We're going to store like 3 or 4 so we don't get kind of out of control here. But right now we're thinking about solving this in real life. So at the very minimum, a patient record will have a first name. It'll have a last name, maybe a middle initial, and let's just have H. I think that'll be a good mix. Okay? So these are the 4 pieces of information we're going to store related to patient records. Okay? So if I were to walk in, it would be Mike Littman, middle initial would be B, and then my age. Did you figure out what it is?
40-something.
40-something. That is correct. It's 40-something. Okay, so we're going to have these 4 pieces of information that we're going to store for our objects. Now, remember, Java is a strongly typed language, which means that for each of these attributes, each of these fields, we're going to have a type associated with this. So if we're going to store a person's first name, for instance, Mike, what kind of value would we need to store the value Mike? What kind of variable type? String. All right, so this dude's going to be a string. What about the last name? All right, what about a middle initial?
Might just be a chart.
Char, good. And age? Int. All right, so pretty good. So we're going to store 4 pieces of information, 4 fields associated with a patient record. 2 of them will be strings, 1 of them will be a char, and 1 of them is going to be an integer. Make sense? All right, so that's what our patient record is going to look like. So everybody's cool with that? That if you were to be running your own ad hoc clinic and you had your patient records written on little note cards, for every one of your patients, you're going to keep track of their first name, last name, middle initial, and age. So this makes sense to everybody from a real life problem perspective? Okay, so now we're going to go and write the Java equivalent of it up to this point. Okay? So what I'm going to do, I'm going to create a new project here. So I opened up Android Studio. There's a link to that in Blackboard if you don't currently still have it installed from last semester. But get Android Studio installed, make sure it's all up to date, all that jazz. All right, so I'm going to start a new Android Studio project here. All right, and we're going to call it, I need to back this up a little bit. Let's just put it in downloads. Let's call this guy patient record example. Okay? And then I'll just hit next. We'll leave everything else. It's going to be phone, tablet. We'll leave it as API 15. Hit next again. And we want to do an empty activity. That's always our starting point. Well, it doesn't always have to be our starting point. It tends to be the starting point I always use for examples because I'm not teaching you how to make amazing interfaces. I'm teaching you how to make ghetto interfaces that show computer science concepts, right? Okay, if you want to make beautiful interfaces, there's all sorts of UX experience tutorials out there and stuff like that. Not my cup of tea. Ours will be functionally mediocre. All right, so we'll hit next. All right, we're going to create a, fine, we'll just name it main2 activity. I wonder why it called it main2, but whatever. So we'll just leave all that alone, hit finish. Why are you upset with me? Oh, maybe I already had a project. That was the problem. I already had a project named that. So I'm just going to go through and do that again. So we're going to call this patient record example 2. It'll be happy with this one. I'm going to put this in downloads. All right, so I'm just storing it inside of downloads, patient record example 2. You can put yours wherever you want to put it, but just make sure it's named uniquely for where you're storing it. That's what it was upset about. Hit next, empty activity. Now it's calling it main activity. It's all happy again. So we'll hit finish, and this will create my project. Okay, it's doing my build crap. Okay, so now let's just to make sure it works. Remember, when you first start a brand new Android application, it gives you like a little hello world example type thing. So let's just make sure this guy is cooking fine. So I'll go ahead and hit play. It's going to ask me what device I want to use. Here, actually, I'm going to hit cancel real quick because I do still have the emulator open here. So I'm just going to kill the emulator so you can see the whole process as if your emulator is not currently launched. All right, so I'll hit play. It's going to show me what my available virtual devices are. We had created one last semester called Pixel API 23 or something. If you don't have any of those, just go to create new virtual device, select phone. I like to use like maybe the original Pixel, doesn't use too much memory, that kind of stuff. So choose Pixel, hit next, and then for your system images, this is what version of Android is on it. It needs to be something that's at least API 15. So if you already have one of these guys downloaded, just use that one, but make sure you use the x86 one. So for instance, on mine here, Oreo is the one that's already downloaded. So if you really wanted to use one of these other ones, you can choose to wait 10 minutes for it to download, or just choose the guy that's there that's at least API 15 or newer, and then hit next. And then ultimately you'll hit finish and it'll create that device for you. Cool? If you don't have any of those guys downloaded, download one of them. Doesn't matter which one, as long as it's API 15 or newer. All right, so I'm going to hit cancel because I already have that. So had I hit finish, it would have given me something like this. So I'm going to go ahead and hit OK. That's the guy I want it to run. And it's launching my Android emulator here. And if everything works out, I should get a little hello world sitting in the middle of the screen there, letting me know that my Android application is running and stuff. We're missing several people, actually. All right, so there's hello world. Everybody's happy? Okay, so we're going to forget about the interface here for a minute because we're focusing on creating an object first. Okay, so we're just going to let that guy sit. Our Android project is working, so we're happy. So I'm going to come up here to our app. I'm going to click on Java. I'm going to click on the very top one. So we have this top folder is where our actual code lives. Android test is for unit testing. And then actually this test is for unit testing. This guy, I don't know what the difference is, but just leave it. So we're going to go in here. Here's my Java file, main activity. Okay, so if I double click on that, this opens up that main activity file that drives that first screen. Okay, but I'm going to go ahead back here, and I'm going to right click on this guy. I'm going to create a new Java class. We're going to create a class for patient record. Okay, because we need a Java class for representing the patient record that we're designing. Make sense? Okay, so I'm going to right click here. I'm going to say new. And we're going to choose a Java class. This has nothing to do with Android. This is a plain Jane Java object. We could be doing this in Eclipse. Okay, so I'm going to choose Java class. We're going to name this guy patient record. All right. The kind is class that's already selected. I'm going to leave everything else alone. So just hit OK. And there's my patient record class. Okay. Now, I like to have my curly braces left justified like that. Very first thing we do, we need to go back and look at our design, right? So we came back in here and we decided a patient record is going to have these 4 fields. It's going to have a first name, a last name, a middle initial, and an age. So we're going to create variables for those 4 things. So I'm going to say private string fname. Actually, let's spell it out. First underscore name. Private string last underscore name. Private char middle initial. Private int age. All right. Now, I made these guys private. Remember when we talked about last semester that have everything locked down as much as possible, then only loosen the reins a little bit if you need them to be. Okay. So we start off by making everything private. That means we can only access it inside of this class. And then we would loosen it if we need to loosen it at a later point in time. Okay. So first things first, here's our public class patient record. We have 4 variables defined here. These are called fields. I'll put a little comment here. These are our fields. And do we all see that those match up directly to what we designed right here? Everybody's cool with that? All right. So as of right now, we've created our own object type. In fact, if we wanted to be super lazy, we can actually just make all of these guys public. And now I can create patient records and say, P dot first name equals this, and P dot last name equals this. That's not the right way to use objects, but you could make it work that way. Okay, I'm going to show you the right way to use them. All right, so now we have our fields. Next thing we need is we need to have a constructor. So I'm going to say, now for starters, let me just show you this. I'm not going to do anything new here. I'll just leave it alone. Let's go over to main activity. I'm going to go ahead and create an instance of our patient record. Okay? So I'm going to say patient record PR is equal to new patient record like that. Now notice it's happy with this. Even though inside of patient record, we did not define a constructor. Make sense? We didn't write one. Yet we're calling upon one right here, passing it no parameters. So in Java, as well as most object-oriented languages, if we do not specifically define our own constructor, a no argument, that is a constructor that takes 0 parameters, will be kind of magically provided for us specifically to make this syntax work. Make sense? Okay. Now, there's a couple of other pieces of information that are of interest to us here. I mentioned in our slide over here that constructors do not have a return type, where methods do have a return type. Okay? So notice here, we have an invisible constructor here. I promise you it does not have a return type. We'll see a real constructor here in a second. Now, based on what you see right here, how we use constructors, why does the constructor not have a return type? This is our constructor right here, correct? Mm-hmm. Okay? That's us calling the constructor, as opposed to us defining the constructor. This is us calling it. Why do constructors not need a return type? Go ahead.
Well, they're basically their own return type, right? You give me kind of a funky look in that. So like, since you're making an instance of that class,
Mm-hmm.
it's then like a new, it's your own data type.
Let's say no.
Let's say no? Okay. I don't know.
We always call constructors using the new keyword.
Mm-hmm.
So a constructor will always follow the new keyword. Remind me what the new keyword is. Real estate agent. What kind of value does the new keyword always boil down to? Memory address. 100% of the time, the new keyword boils down to a memory address. 100% of the time, when you're calling upon a constructor, it will be preceded by the new keyword. Therefore, the return type of a constructor will always, 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 always be a memory address. Therefore, Java doesn't make us say what the return type is because it already knows what it will be. Make sense? Some older object-oriented languages will have return types for constructors, and there'll be a return type that will be like a void pointer or an ID, something that is that language's type for a memory address. Java, first of all, does not have a specific syntax for pointers for memory addresses. Therefore, we don't have anything to put in there anyways. But Java is also smart enough to know that, hey, this is a constructor. You always precede a constructor with a new keyword. The new keyword always returns a memory address. Therefore, constructors don't require a return type because it will be a memory address. Make sense? Okay. But, so if I were to come out here and I would say system.out.println PR, we'll get a crazy looking memory address that gets spit to the screen. Okay? But when we build a patient record, we really want a patient record to have a first name and a last name and a middle initial and an age. So this little default constructor that they give us just to make this syntax work really isn't up to the task of building patient records for us. It doesn't do enough, right? So we can't just utilize that default one. We should write our own. So let's go back into patient record. So we're going to go ahead and we're going to write our own constructor here. So I'm going to say public patient record. So the name of the constructor must always match the name of the class. All right. And we are going to say that patient records require 4 pieces of information. We need a first name, we need a last name, we need a middle initial, we need an age. Give me those 4 pieces of information and I will build you a patient record. That's what constructors do. They build instances of objects. Make sense? All right, so for our comma delimited list of inputs here, now I'm going to name them identically to how I named them up here. Variables should always have a meaningful name. Okay? And if I want to read in a first name, variable name first name makes a lot of sense, right? So we're going to go ahead and use those same names. So we're going to take in a string first name, a string last name, a char middle initial, and an int age. Those are the 4 inputs that we need. Okay? Now, before I do anything else here, we want to go back and we want to see the error that just was created for us. So I'm going to jump back over here. Notice that this guy is no longer happy. All right? So I told you that if we do not write our own constructor, Java will magically create a no argument one for us. Okay? But in this case, we did write our own constructor. Therefore, Java's going to say, you got this. We're not going to give you that default one.
So if we didn't define our own constructor, what would we do with the default constructor that they provided for us, like just in terms of usability?
Well, you wouldn't. I mean, the only reason this constructor even exists is so that you can get an instance of that class.
Right.
So the only time you would use that default constructor is if you actually had a class that didn't require inputs for the constructor.
Oh, so you're just grabbing an instance of the class.
Yeah, that's what this new keyword does. It says, I'm going to create a new instance of this class. So in that particular case, that class maybe just does a whole bunch of things.
Okay.
Maybe it's like the math class and, does cosines and sines and stuff like that. Doesn't actually take any inputs. Or maybe it makes a random number input or something like that. All right, so they provide you with a constructor that takes no parameters in the event that it doesn't really make sense for your particular object to have a constructor. You still need one for the syntax to work. Okay, but it's probably fair to say that a very high percentage of the time when we write our own objects, we're going to need a constructor. Because usually we're writing our objects to represent something like this. Or creating a patient record or a player, okay, or something like that. These are things that are going to have attributes or fields associated with them, and we're probably going to need a special constructor for that. Okay, so this is an error now because we wrote our own version of the constructor, so now it expects us to call something that has 4 inputs. Go ahead.
Is the string first name is the same as the one that you...
Yeah, we're getting there. That's the next thing we're doing. So we really want this guy to be equal to this guy, right? That's what we want to say. These are 2 separate variables, but we want this guy to equal this guy. So I'm gonna show what we want to do, and then we're gonna talk about why it's a problem. First name is equal to first name. last name is equal to last name. Middle initial is equal to middle initial. Age is equal to age. Okay? Now, what we want to happen here is we want this version of first name to be equal to this version of first name. That's what we want to accomplish here. But that's not what we're actually accomplishing right now. All right? Now, what lesser programmers would do is they would cheat. They might come up here and say something like, well, we'll just call this guy FN. So now we can say first name is equal to FN, and oh, it works. That make sense?
Mm-hmm.
Why does that work where the other one didn't?
Because it's trying to access like the local variable.
How do variables get resolved? Variables resolve to their most local definition. So when I say last name is equal to last name, this variable here, this version of last name, resolves to its most local definition, which is that local scope there. And this version of last name also resolves to its most local definition, which is that guy right there. So we're setting the variable equal to itself. Not what we actually want. We want this version of last name. So we want the version of last name that is owned by this particular instance of the patient record. How do we reference this particular instance of the patient record? This dot. So we'll say this dot last name. When I put this in front of it, we're saying I want the instance of patient record that we're currently working with. I want his field, name, last name. That's this dude right up here. And I want to set that equal to last name. That is the most local definition of last name, which is this dude right here. Make sense?
So is it that this referred to the patient record?
Say that again?
Is it that this one referred to like the patient record?
Yeah, this is this particular instance of patient record. So if I were to print out the value of this in here, it would match if I were to print out PR out here. They would be the same memory address. Okay, so the this keyword, just throw that in our notes because it's super important. Just remind us of this keyword. This keyword. This, let's just say, is how an object refers to itself from within itself. When I am inside the constructor, for example, of patient record, I don't have access to that variable that was out there in my main activity called PR. When I'm out here in main activity, this variable PR is a local variable to onCreate. Right? So I don't have access. If I'm inside of patient record here, I don't have access to a variable called PR. I might really want to say, I want PR's last name to be equal to last name. That's really what I mean. Okay? Because I know I defined a variable out here called PR. But I don't have access to that variable. That variable has a local scope to onCreate here. So when I am inside of patient record, if I want to set this particular instance of patient record's last name equal to this local version of last name, the way the way an object accesses itself from within itself, because right now I'm inside of patient record, is through the keyword this. Make sense? This instance of patient record. We'll go ahead and switch this guy back to first name so we're not lazy. And now we put a this dot in front of there. Same thing for those things. So far, so good? Okay. So, What day of the week is today? Tuesday?
Tuesday.
So we're done at 11:20.
Yeah.
Good, perfect.
We've got it.
All right. So, we have our 4 things now that got set. So now I'll go ahead and call upon my constructor. Notice it's still not happy because I'm trying to call a constructor that takes 0 parameters. And when I look at patient record, notice that I do not have a constructor that takes 0 parameters. I have a constructor that takes 4 parameters. Therefore, I should probably call that one. Okay? And I need to pass it a first name as a string, a last name as a string, a middle initial as a char, and an age as an int. So I'm going to pass it Mike Littman. Middle initial is B. And age, what did you decide my age was?
41.
I think 41. Did you look it up? It is 41. Most people pick a lot higher because I've been teaching for 19 years. So that means I started teaching when I was 21.
Really?
Yeah.
I feel like you told me 40 last year.
Hmm?
Because I feel like you told me 40 last year.
I was 40 last year. That's why I'm 41 this year.
That's true.
Maybe you thought it was more of like a weight-based thing. Like if you weigh enough, you actually it's like you go up by like a power of 2.
Yeah.
Yeah, seriously, they say it goes downhill when you hit 30. That's totally true. For me, it was 18. Broke my back at 18, but even through my 20s, I felt pretty good. At 30, I can't no longer pull all-nighters. You know, your ears start ringing at 2 a.m. You know, at 40, you're taking midday naps. Like, not because you're a lazy student, you just take naps because you like sleeping, but because, like, you can't stay awake. Like, you try to make it through a TV show, and the next thing you know, your DVR is asking you if you want to delete the show. it's run its fruition, and you only made it through like 4 minutes of it. That's pretty bad.
Yeah, it sounds like a bad time.
All right, so now I've created an instance of patient record. Make sense? Okay. So now I maybe would like to do things with this instance. So now my patient record as of right now only knows how to hold some pieces of information. And it just so happens that all of those pieces of information are private. So I can't get at any of them. All right, let me show you that. So let's say that I wanted to do a system.out.println pr.h. Okay, if I want my age. It's all unhappy now because it says that age has private access. Now, when a variable is private, that means you can only access it inside of the class in which it was defined. Right now, I'm inside of a class called main activity. That variable was defined inside of a class called patient record. Main activity is a different class than patient record. Can't access it there. Now, if I wanted to be lazy, I can come here and just say, well, there we go. Make it public. All of a sudden, boom, it works. Public says you can access it everywhere. No harm, no foul. Okay, so if I go ahead and run this, my device is already connected. I'm just going to hit this checkbox that says use the same selection for future launches. That way I don't have to keep hitting OK every single time I hit play. All right, it's going to still show me hello world because we haven't done anything with our interface. But I'm going to click on logcat here. And I'm just going to type in system.out in here for my, I haven't set it verbose, which will show me all the stuff. Like logcat says, here's all the console output of your Android application. Okay? But I specifically said system.out in here because that allows me to specifically see the system.out stuff that I wrote there because it flags it in a certain way. You just notice if I don't say that there, I have like this giant wall of crap. So it might be a little hard to find the stuff you printed out. So this is more just a quick little cheat. All right, so there's the age, 41, associated with PR. Okay, now, like I said, we want to, as good programmers, we want to keep our fields as locked down as possible. So what we're going to go ahead and do is we're going to go ahead and switch this guy back to private. So now he's not happy with his code anymore, because now it's private. So what I'm going to do is I'm going to say, you know what? We're not going to let them change the first name, the last name, the middle initial, or the age, but we probably want to give them read-only access to that so we can get at those values, right? Mm-hmm. So we can go ahead and write a method. Maybe we have a method here, public int, maybe we call this guy getAge. So this guy is a public method. That means we can access it outside of this class. It's going to return an integer, Luke. The name of the method will be getAge. It takes no parameters. Why do we not need it to take any parameters? Because we already know about the age. So this guy is going to return this .age. Does that make sense? So what I've done here is I've given myself access to that private variable. But I've given myself only read access to it. I can't change it. Where when I had that guy public, I could have said pr.age is equal to 5. I could have changed that value. All right, so I'm giving myself now public access to this private field, but it's only giving me read access to it. So now out here, instead of saying pr.age, I'm going to say pr.getAge. Make sense? And that'll give me my 41 again. All right, now, as another review, notice that I do not have the static keyword in front of that method. So when the static keyword is missing, that means it is an instance method. Okay, no static keyword means it's an instance method. How do we call instance methods? Using an instance of the class in which the method was defined. What class was this method defined within? Inside of a class called patient record. If I go out here to main activity, here's my instance of patient record. I am then using that instance to call that instance method. Make sense? Okay. And for this semester, when I ask questions about static versus non-static, okay, anytime you miss it, not only do you lose the points for that, you'll lose double the points, so it'll take points off of something else. Gotta understand instance versus class methods this semester. In fact, if you miss it once, it's probably just a 0 for the semester. It's the way it goes. All right. Now, Android Studio as well as Eclipse do give us some nice little tools for things like this. So we just saw we can write those getters ourselves, right? Okay, but similarly, I can go in here and I can right click and I can go down to this option that says generate. I can click on that and it gives me some options here. I'm gonna generate a getter. Getters are methods that allow us to get at the value of a private member, a private field. Won't let us change it. That's a setter. Setters let us change it. Getters will give us read-only access to it. So I'm going to create a getter, and notice it doesn't have a getter for age because I already have one that I wrote, but it does have for first name, last name, and middle initial. So I'll select all three of those, and then just hit OK, and it'll write those methods for us. So a nice little convenience thing. All right. So understand that these getters give us read-only access to those private fields. If I wanted to be able to change the value of my age, I might say something like public void set age int age, and then say this dot age is equal to age.
How do you get the getter again?
Oh, you, here, let me just delete these first. Otherwise, none of them will show up. So first of all, you have to have private fields.
Mm-hmm.
Then just right click, go down to generate, then getter, and then select all of your private fields that you want to have getters for. All right, so notice I have a getter for age, but I also have a setter for age. So with that setter for age, I can come in here and I can say pr.setAge to 5. And that will set the person's age to 5. Okay, I've updated it. Go ahead.
So you can just update it whichever one whenever you want.
If you have a setter for it. Yep. Now, if I'm doing it this way, you might say, well, if you have a getter and you have a setter, why didn't you just make it public? Right? I have effectively read and write access to it. The reason is that if I just make it public, I can set the age to whatever I want. As I have this written right now, I can still set the age to whatever I want. But maybe we decide that we don't want to let them change the age to something below 1. So now I can throw logic in here. I can say if age is greater than or equal to 1, then we'll let them go ahead and change it. So by making it private and then using a setter, we can add some logic to that setter to control how that value is modified. Okay, so now if I try to set the age to -6, it's not going to actually change the age because this if statement will fail. That makes sense? The benefit of doing it inside of a setter versus just making it a public variable, which is just a free-for-all.
Mm-hmm.
Now, the reality is if you're just writing a quick object just for solving some little problem, it's a throwaway code that you're never going to use again, maybe you just make it public and move on with life so it's nice and fast. You don't have to write all these getters and setters and stuff like that. But if you're writing code that's part of a project that's going to be an ongoing type thing, you should write proper object-oriented code, and this is an example of that. Lock it down, then give yourself access as you need access. Right, make some sense? Okay, so I'll leave that in there just so you have an example of a setter, even though we're not gonna need those things in our example here. Okay, so now I have a patient record that lets me read in these 4 things into these 4 fields. This guy right here is an example of a constructor. And these guys down here, they're technically methods, but I'm going to say getter/setter methods because they're a getter and a setter isn't actually any sort of special method. It just happens to be called that because they allow us to manipulate private fields. Okay, but we're going to go ahead and we're going to write a normal method. So I'm going to say something like public void display. All right, and what this display method is going to do is it's going to kind of show this patient record in some sort of like friendly looking format. Okay, so we're going to say system.out. Here, I'll show you format again in a second, but let's just do a println. And we're going to show their first name, followed by a space, followed by their last name, actually followed by their middle initial, followed by a space, followed by their last name, and then maybe followed by open parenthesis, then their age, and then close parenthesis, something like that. So we're going to go ahead and say this dot first name concatenated with a space. This dot middle initial concatenated with a space. This dot last name concatenated with a space followed by an opening parenthesis. And then this dot age concatenated with a closing parenthesis. So we'll print out that string. So kind of a pretty print version of a patient record. Okay, so this display method does not return a value, Luke. Instead, it prints out a value. Got it? So with that in mind, it would not make sense to do this, pr.display. Notice it's not happy with me because pr.display doesn't return anything. How do we know? Because its return type is void. Instead, the display method is a non-static method, therefore it's an instance method, therefore we call it using an instance of the class in which the method was defined. What class was this method defined in? Inside of a class called patient record. So we're going to need an instance of patient record to call it. We have one right here called PR. We'll use that to call display, but display does not return a value. Instead, display goes ahead and prints a value for us. So I'll just get it out of there. And we'll just go ahead and ask that object to display itself. Make sense? Go ahead and hit play. I'll click on my logcat here. We still have our system.out.println, and there's our pretty print Mike B. Littman 41 in parentheses. Make sense? All right. Now, in case you actually for, well, let's just do it real quick. System.out.format. I'm going to say %s, %c, %s, opening parenthesis, %i, close parenthesis, this dot first name, this dot middle initial, this dot last name, this dot age. Comment that out. Let me just make sure this works first because I'm using C-style placeholders there. I just want to make sure it's right before I pass it off as accurate code. Does not like %i, so in C it's %d. Let's see if it likes that guy. Launch. Yeah, so it looks the same. So this worked. So this is, instead of having all these concatenations strung together like this, you can actually write your string. So this is a placeholder for a string, followed by a space, followed by a placeholder for a char, followed by a space, followed by a placeholder for a string, followed by a space, followed by an open parenthesis, followed by a placeholder for a decimal number, followed by a closing parenthesis. And then for each one of these placeholders, you should have a variable over here. So there's 4 of them here, right? Here's 1, 2, 3, 4. And it'll match these variables. So this first variable matches up to the first placeholder. This guy matches up to the second. This guy matches up to the third. This guy matches up to the fourth. Okay, so just kind of a convenient way for doing those things. All right, so now what we want to have is we're going to go ahead and we're going to create a form for adding patient records. So I'm going to come over here to my activity main. I'm going to go ahead and take that guy out. And just for the sake of argument here, I'm going to put our layout. We'll give ourselves a vertical linear layout because that's how I like to build them. And then at the very top here, I'm going to put a button. And I'm going to make the text in that button say, add patient record, like that. So now when we click this button, I'm going to have it take us to another screen. Because what we're going to do next class, and I have to update the homework assignment a little bit, is we're going to have a list view of all the patient records we've added in here. But for right now, we're just going to go ahead and create this screen that allows us to add a patient record. So when I click this button, it's going to take us to a new activity. Okay? So I'm going to go ahead and give myself the function that this button will call. So that's inside of main activity here. So I'll say public void on, let's call this add patient record pressed. This guy takes a view. V is a parameter. Okay. Go back out here to our main now. So this function will get called by the on-click event of that button. So since I've written it now, and remember it has to be public, it has to be void, and it has to take a view as a parameter. You can name that variable whatever you want here, and you can name this method whatever you want. But all the other stuff needs to be exactly like this. So I go back out here, and I click on the button, and I go to on-click. Notice that add patient record pressed shows up there. So I'll select that. So now I've connected those two. That's MVC, right? Mm-hmm. Model view controller. So my controller is the Java code. The view is my view here. And now I've connected my view and my code together using MVC, using the on-click button there. All right. And then what we want this to do is we want it to take us to another screen. So I'm going to go back out here to my project. I'm going to click on this patient record example thing. I'm going to right click. I'm going to say new, and I'm creating a new activity. It's going to be an empty activity. Okay, and we're going to call this guy patient record add new activity. This is going to be my activity, allows me to add a new patient record. Okay? Call it whatever you want, but it seems to be reasonable enough. I'll go ahead and let it generate the layout file for me. It is not a launcher activity, so just leave that alone. Source language is Java as opposed to Kotlin, so just leave everything default. Go ahead and hit finish. It's going to create a new activity for me. Okay. Now, in this activity, this guy right here, I want to have a form for adding in a first name, a middle initial, a last name, and an age. So I need to have four input boxes. Okay? Let me do this, then this. So I'll go ahead and create my vertical linear layout in here, drop that in. And then I'm going to give myself four edit texts. So for my name, is there something better than plain text? Nope, looks like we'll be plain text for that. So first name will be plain text. Middle initial will be plain text. Last name will be plain text, and our age will be a number. Okay? Now, these are actually all just edit text boxes. The difference is when I made that last one a number, it'll just show a keyboard that has numbers on it to kind of self-police it. But for us, we'll just assume that you're entering in decent information. All right? So I'm going to go ahead and set the hint for each of these. So we're going to say first name. And I'll take the current text out of there. For this guy, I'll set the hint to middle initial. And take the text out of there. We'll set the hint to last name. Take the text out of there. And we'll set the hint to age. All right, like that. Then we'll go ahead and throw a button in there. And we'll set the text in this button to say add new. Or we'll just call it add. All right, so the idea is we'll fill in these 4 fields, hit add, and that will add a new patient record. Make sense? All right, so let's first get us to this page from our other button. So I'll go to our main activity. And on that button click there, we're going to create an intent. So we're going to say intent I is equal to new intent from this context, and we're going to patient record add new activity dot class. That's where this guy's going to go to. And then we'll say this dot start. Start activity I. So when we click that button, we're going to create an intent to go to a different screen from our current screen. Then we'll ask our current screen to go ahead and start that activity. So this should take us to that second screen, which currently doesn't have any functionality. It just looks pretty. So I click add patient record. It takes me here. Here's my 4 edit texts. When we click add, we want something to happen. So let's go to this patient record, add new activity. We're going to go ahead and create a function for that button to call. So it's going to be public void on add button pressed UV. All right, and then let's go ahead and connect that guy up. Click on my add button, hit on click. Here's my on add button pressed. It's available to us over there. So now when I click this button, we want to go ahead and read in from these 4 things and create a new patient record. So I'm going to name this guy. I'm going to name this guy first name. Well, I'm going to call it first name ET. We'll call this guy middle initial ET for edit text. We'll call this guy last name ET. And we'll call this guy age ET. All right. So then when we hit add, we want to go ahead and create a new instance of that guy. So give me 30 seconds to just write that code here real quick. And that way you have a good starting point for your assignment. So I'm going to give myself access to those 4 edit texts. I'm going to say edit text. First name ET is equal to the edit text version of this dot find view by ID, r dot ID dot first name ET. This would be last name. This will be middle initial. This will be age. All right, so now I have those 4 pieces of information. I'll go ahead and I'll just create a local patient record here. Patient record PR is equal to a new patient record. I need to pass it a first name, a middle initial, a last name. So we're going to say first name ET dot get text dot toString. Then a middle initial ET dot get text dot toString dot char at 0, since it's only going to be a single char. Kick this down a line. Then last name et.getText.toString. And then integer.parseInt age et.getText.toString. Then we'll tell that guy to display itself. So that's that. That is text.toString.
Oh, I think it's trying to take the middle initial after last name.
ToString. Should be good. Last name, get text.toString. Is it not like me kicking it down to another line?
I think it's the order of the parameters.
I don't think so. Doesn't patient record take... Oh, it takes last name second. I thought it took middle initial second. It's kind of a bad design. Who wrote that? All right, so we'll read in our patient record, and then we'll just tell it to display it. So run this real quick. I should be able to put in my 4 pieces of information, hit the add button, it'll just spit it out to the screen. So what I'll do is I'm going to give this to you. I'll upload this to GitHub. I'll keep it on the video if you need to run to your next class. But so you'll see how to upload it to GitHub. And your homework is already up. I'm going to slightly modify it so it doesn't do the list view. That we'll do that next class. So your job is to like for a basketball team. So you'll create a object for a basketball player, hit a button for like add player. I'll put in name. And then I'll hit add. That should have just created it. Here's my log cat. Well, it's printed in there somewhere. We saw when I hit play, it ran.
Yeah.
All right, so that's what your homework is create your little form for adding a basketball player, hit the add button, it'll create an instance of that guy and display it. All right, so that's practice writing objects. Next class, we'll look at list views because we're going to create a list of patient records and then have them display on a screen so that we can click them and see a detail. All right, so I'll go ahead and check this into import into version control. Share project on GitHub. So you'll have to create an account on github.com. And I'll just hit share. And it's now.
Austin fixed it for me the other day.
And there's my code. All right, so I'll give you this code as a starting point so you can reference it. All right, I'll see everybody on Thursday. I'll give you a link to the keynote. I'll give you a link to the videos, and I'll put the link up for the homework assignment.
That's by Thursday.
Yeah, due Thursday.